Okay, we're live. Then let me. So, I have something super simple to cover today, which should not take more than half an hour, and then we can move on to questions if anyone have any questions. But I'm gonna start by just going through this because Fernando asked me to, and then we can take a step back and see if where we are. Because I'm also thinking that this is probably the last session. There is nothing that I need to cover anymore. I'll still be available to help you all with any questions you have throughout the semester. But the bulk of what you need to know is done. And yeah, so I'm gonna show you how to do the lag, the problems that you might encounter when lagging. And I did an example creating a function to do what we're doing today, not because this is going to be necessarily a helpful function, but just as an example of how to build a function. But we can also later, if everyone wants that, because I mentioned before, doing a session on functions in general. Which we can kind of, I don't know, together build a function for something. I can also send an exercise of some kind of building a function and then go through that if people are interested in learning more on how to do that, because sometimes it's much more convenient to be able to create a function than do the same thing over and over and over. Okay, so basically, if you want to go on chapter 11 from Fernando's, he created this function called lag, which is actually the same as the function shift. I was asking him earlier today, why did he create a function called lag that does exactly the same thing as the function shift? As you can see here, basically he calls lag the function which shifts. And shift is itself the function that shifts. And he said that earlier, on an earlier version of our fill and a was not the default, but now it is. And also he thought that the name lag is less of a mouthful than the name shift and less confusing. But anyways, so these are the reasons he said he did that. But we will still look into the function lag, which just shifts. And then he also created this function dd, which shifts and takes the difference. So basically, when you start working with time series data, which I'm not really sure if he already started doing or not, has he?
Okay. I think that's our next session.
Okay, so basically when you start working with time data, time series data, one of the dependent variables is frequently lags of a certain variable. So you expect that to predict the future, whatever happened in the past is a good predictor. So if you do want to add to your model the lag of a function, you first need to create a variable which is just basically the same as a certain variable but lagged. So an x t minus 1 is just x, except that you are regressing it with one lag of time. So you look into, in this case, he's going to look into the variable return and regress it with the return of last year or last month or whatever, depending on what is is the frequency of your data. So you can say, for example, that the GDP of this trimester is going to be a function of GDP of last trimester, for example. And then you would run a model where basically you're just predicting GDP as a function of past GDP. So to do that, first he creates this lag function, and for that I'm gonna look. So what shift does is that it basically takes your whole data and shifts by n, which this would be if you're talking, if you want to say that y is a function of if you want to regress x in x t minus 1, n would be 1. If you want to look into t minus 2, n would be 2, and so on and so forth. So you shift it by how many time lags you want. And this data is going to fill the beginning with an ace, because basically what happens is when you want to look into t minus 1, you're not going to have, and you're saying that t minus x on t minus 1, you are going to regress that against x. You do not have the very first observation, because you do not have your data starts at x. You do not know. So let's say that your data starts in 1970, and it's an annual data. You do not have an observation of 1969, which means that you're going to lose one observation of your data when you're doing a lag of it. So this first observation is going to be an NA, because basically what you have is that, so let me show you. So what you would have here, so return here is a data that you have, which is already lagged according with respect to price, apparently. So you have on time t2, you have an observation of what is the return. When you create a lag of return, what you have here is supposed to be the observation of return on the time before, which you don't have. So this is an NA. And basically this is just a shift of this data. Therefore, you need to put an NA in the beginning, and you also just cut it short at the end. So this very last observation of return is not gonna come here. Okay, so shift already does that. It already fills the NA in the beginning and cuts at the end, which is very convenient because you can just attach that to the data set that you already had. And you can also regress. So when you're doing DLM, if you had just shift all the return but kept the last one, the size of those sets would not be the same and you would have a problem. So you need the dimensions to be the same, which is also the problem we're going to have with then attaching the predicted part, which I'm going to explain at the end. So the lag function shifts your whatever data you want, your variable that you decide, or X could actually be a whole data set. You could be shifting all of your variables by N. So in this case, we're going to shift it by 1. And he's setting here 1 as the default, but you can change that if you want. You're going to fill whatever is the shifted part with an ace, and the type is lag. So shift has also other options, which we're not going to look into. And then he also created a DD function, which is the difference. So this is X minus X t minus 1. So basically here he's going to look into return minus return from the last time. So this is a function where the only thing you're doing is that you're subtracting from your data the lag of the data. Okay. So then what you can do is that you can regress return against the lag of return. Oh, that's not going to do because I didn't create the function. And there you have it. But then, so let me actually show you something. So let's say that I do this as an example 1. And then I want to predict EX1. And when I predict, when I predict EX1, it actually starts on 3. So let's call this the prediction for a second here. Oh, sorry. So when I look into the length of my prediction is 689. And the length of my original data, or of each column, was 691. So if I try to attach to prediction to the data, my new prediction, or if I'm trying to do something using my prediction and the original data, I'm going to have a problem because they do not have the same length. So the next thing I will need to do is also add NAs to the beginning of my prediction so those have the same length. So to do that, now I'm going into what I've done here. So this is basically the same thing, using as an example the return, and then here actually I'm calling it pred, which is the same as the prediction before. So then what I want to do is, if I want to reattach this example, now first let's call data here what I had before, right? So now my data is exactly this. Let me close the door 1 second. And now what I want to do is I took the return and the lag of the return, which actually in this data set already existed. So you didn't actually need to do the lag for this data set, but we're doing that. So instead of actually taking the return 1 here, we are lagging return, doing an LM between return and the lag of return, and then predicting the result. And then I want to attach that as a new column here, but I cannot do that because that column doesn't have the same length. So I have my data. I created my LM, and then I predicted. And then if I try to do data at prediction and attach that there, it's gonna say replacement has 689 rows, data has 691. So the first thing I need to do, and I know this is 2 of difference, right? And I need to put in the beginning. So what I could do is just, instead of attaching the pred, is adding to pred NA and NA. So I could create a column NA and A. And then add that column to an R bind between NA and A and pred. Let's see if this is gonna work. Pred 2. Did not work apparently. You don't get it. 1 and A. So let's do a R bind of replicating an A twice. And now we have our prediction with 2 NAs in the beginning. Okay. But if I want to make this more consistent and also something that I can replicate easily depending on how many legs. So let's say that I actually had done 2 legs here instead of 1. then I would have needed to add 3 NAs, right? So one way of doing that is that you replicate your NA by the difference between the sizes of the data you want to attach it to and what you just created. So here I create this little n here, which is just NA and NA. And then you can attach to your data now the prediction there at the end, which comes here. Actually, this is wrong. I'm sorry. What I actually need to do is, I need to do this the other way around. I need to R-bind. Okay, sorry. So this is what I actually need to do. I need to add an NA in the beginning and another NA at the end. So this is the prediction of the return, not the prediction of the lag of the return. So basically what we have here is that we do not have the first observation because of the lag here, but we also do not have the last observation. Because, so the reason why we do not have the last observation we could have had, no, we couldn't. It's because this ends here and we're not regressing that against the next one that we could have there. Everyone understands this part?
One question, how do you add the NA at the end of the vector?
Yeah, so what I did now is that I've added an NA in the beginning and our bind, it's the row bind. I added one NA in the beginning, the prediction, and one NA at the end. So this here is not actually gonna work. So I need to think a little more if I was doing more than one lag, how to make this more automatic, but. Oh. Do you understand, Andreas, here, how I did that?
Yeah, I understood that part. And for the 2 lags would be two NAs at the beginning and 2 at the end?
Yes, I think so.
So for every NA we put in NA, we don't put in like NA comma 2.
Let's do a test. How about that? Yeah. So actually, let me. So what you would have is replicate NA, replicate the NA. Mm-hmm. That's weird. Oh, no, you still have 1 in the beginning. You would add 2 in the beginning, but still 1 at the end. I'm confusing everyone now. So you're gonna add 1 leg in the beginning and then this at the end. Yep. So in this case, what you would have, if you have 2 legs, this is not correct. It's 2 at the beginning and if you had 2 legs, you would add 2 at the beginning. So if you had 2 legs, you would be legging it twice. And then this is the prediction of that. And then you do not have the last observation. I think that's how it is, but yeah. Yeah, because the first prediction that you would have is actually for the 3rd observation. The very 2 ones when you lag twice. Okay, so.
Sorry, can you explain again why we don't have the prediction for the last observation if we're still lagging twice?
That's just, I mean, I think you could have, is because. Why? Yeah, you should have. I'm actually a bit confused here.
Maybe if you try the previous function, but without the C and A at the end.
No, it's not that. The question is, when I predict this, so I'm running, so let's start with the first leg, only one leg. I'm doing a model where my dependent variable is return and the independent variable is 1 leg of return. And then what I'm predicting at the end is return. The very first prediction I'm gonna have is for this value.
Yeah, it seems correct to me. Yeah.
But I'm predicting this value using this. So the last prediction that I do, which is using this observation, and that is actually for the time before. That's very weird. I'm very confused. I'm sorry. The very first prediction is actually on the 3rd observation that I have here. That's when I have a full observation.
Then I think it would make sense to have an NA at the end, because for the last observation you don't have the next time, the next return, so you cannot, I don't know how to explain it, but you don't have like those two values to predict the last one. So probably that's why it's an NA.
Yeah. So that's the thing. The X, the Y is should be aligned with the X and not with the X t minus 1. But you also have 2 missing values because the X minus 1 is 2 missing values. So when I shift it up, I'm missing one at the bottom as well. Where's my predict with 1 here? When did I do 2 legs again? Confused what I'm doing. Yeah, now it's correct. Okay, that's what I didn't do. Okay, here. So this is the prediction of what is going to be X based on this information. That's I'm actually not very convinced of this part. I'll need to ask Fernando. I'm not convinced if this is supposed to be aligned here or if this is supposed to be aligned here, actually. Anyone? Opinion?
One question, just one question. Do you get negative values for predictions? Because I don't. It seems to me there are not many.
Not in, yeah, here.
Okay. Okay. Confused.
No, I don't know. I think I actually should shift twice. This is confusing me because this is so similar to this value. But this is basically the prediction of what will be returned if return last period was this. This is the prediction of what will be the return if the return on the last period was that. So I think what we had before was correct. I'm so sorry. Let's do a little.
It's okay. We are also very confused.
Yeah, but that's my fault. I'm confusing you. Yeah, this would be the, Yeah, so when you look into the fitted values, what you have here is that the fitted value for the third observation is that. So 0.379 is x3. So I am supposed to shift it twice. So this is correct. I'm fitting this to 3, to the third observation. Okay. It's just, yeah, that the model apparently expects the return to be very similar to whatever it was here. Okay, so in that case, this was correct. So once you have your prediction, you're gonna shift it by the difference between the data that you had and the length of your predicted value. So if you're using the code like this, where you actually use the data here, if you're shifting more than once or more than twice, that would still fit it without having to change the code here, which it wouldn't if you're just replicating NA twice instead of by the length. So then what I did is I created a function that lags, predicts, and attach to the data. And then at the very end, what you have is already your data with the 9 variables. So right now I have this data here where I attach my prediction, and it looks like this. And then I also created a function, which is this one, that when I run the lag predict into Nassif data and return, it will already create a data 2 that is exactly the same thing with the prediction attached to it and shift by 2. So I'm gonna go now through the function so you can see how you build a function in general. Everyone understands up to now?
Yeah.
Okay, so your lag predict, which is the function that I'm calling, is going to be a function with 3 arguments. The first one is the data set, which I'm calling data name. The second one is the variable name. And the third one is how many lags. So given a certain data set and choosing one specific variable to lag by any times, this will run an LM between x and xt minus n, fit the prediction for x as a function of xt minus n, and attach that to the original data set. Okay? So I do that by first, so it's very similar to what I did there before, where I first created a data, which is the data set that I had, which frequently you're already going to have. It's not the case here because we're using data from Woodridge, right? So we don't need to upload the data. So if you were uploading the data already, you wouldn't necessarily need this line, but this line is fine. It would just attach it there. And I'm also attaching the data so I can call name here without having trouble. So the very first part would be to attach the data that I'm using. Then I run an LM between name, and remember name here is going to be return, and data here, or data name, is going to be Nassif. Okay. So here I just created, let's go line by line. This is one of the best ways I find to actually look into a function, is assign to the arguments that are going to have an example of a value and go line by line and see what it's doing. So if my data name is knees and my name is return, the first line here is creating a data here, which is just knees. The second line is attaching knees. So I do not need to do here knee. So basically this is allowing me not to use that, right? Not to have to say that, but being able to just say return, and knowing that when I say return, I'm talking about knees $ return. This is why I attach here. That's also because if I just added data $name here, you would not understand, because data name $name is in itself an argument. So when you then you would need to actually add other lines for it to understand name as actually a name, a quote name. So I'm avoiding that by using the attach here. Then I created my LM, which is the same I've done before. Oh, sorry. So this is giving me an error because I did not set n to be 1. So when I'm using n here, so this is the other argument, right? So I also need to do that. Assign the value 1 to n, so this works. So now it works. So my example now is the model, the LM, okay? Then my prediction is gonna be the predict, and I'm already making that a matrix so I can R-bind. And then I'm gonna have my fill for the beginning, which is the replication of the NAs that I need. And I'm also making that into a matrix so I can R-bind. And then I'm attaching to result, which I created here, the R-bind between NA and my prediction. So here already on my result, I have the same thing as the data before. But because this is a function, all of this is things that will be running inside the function once you create the function. At the end of a function, you can decide of all of these things that were calculated here, what do I want it to return to me? What is it that when I say lag predict and argument, that I get out of it? So this is what the return does. So this is telling then at the end, return to me result, which at the very end is the data attached by the prediction of it with the same length as your data. So then when I do that, I'm gonna have my data 2 being exactly equal to what was the result. Everyone understands? Now let's take 2 steps back. Everyone understands how to lag.
Yes.
Everyone understands that once you lag and you predict, you have a problem with the different lengths. Anyone have questions with that? Why is it that we have a problem with the lengths?
No questions.
And that then we need to prepare that prediction so we're able to retouch it. And also if we want to plot and things like that, we want this prediction to be equal to have the same size as our original data. So at the end, we want our prediction for X and X itself to be comparable, right? So now here at the end, I could be the same as what we already have there. So here I'm plotting my prediction against my original data. So this is X, X predicted, and this is X.
So when you do the lag and you create the data set data 2, because we needed the data information from the lag, we will change our regression to use the data within data 2 and not the original data. Is that what I'm understanding?
I don't understand. Can you repeat, please?
So like when we do the lag for, you know, adding the column of return, and you created data 2, so that's a different set of data with the original data.
So data 2, the original data 2 is the original data with an extra column, which is my prediction.
Okay, yes.
Okay.
I understand, yes.
So the main thing is lagging is super easy, and then you can run an LM between return and return lag. That's not a problem. The problem is the only thing where why Fernando asked me to go through this today is that at the end, the prediction of this is going to have a different dimension than return, and then you would have a problem.
Okay.
Because you do not have a prediction for the first observation. So your prediction is going to be lagged just like your lag is lagged. Except that the lag function already attaches the NAs at the beginning, while your prediction does not. When you predict, you're not attaching those NAs at the beginning. So your LM model, so when you run your LM, so let me do this again here, just so you see. Let me see if here it does. Oh, I need the summary, yeah. Let's look at the summary. So summary of the LM between return and lag. 2 observations deleted due to missingness. So then your predict from this LM, as I was showing before, which is the fitted values for your LM here, they start at t = 3. And so this column here only has 689 lines, while your original data had 691 lines.
I see.
So then the last part, what we're doing is attaching to this fitted values that start at 3, 2 NAs at the beginning so that they have the same length. Another alternative, what you could have done is just throw out the first 2 observations. So instead, you could have taken your data. So let's create here a data 3, just so I show you. And that data 3 is going to be your data. Work. Nope. Ah, thinking columns. So now this is just taking the cell. Oh my goodness. So, oh my God. Okay. So another option, I can go in details how to do that. Another option is actually to cut your data, start on the third, and then you can just add the prediction. And then you would just take then your prediction would fit. So that's the second solution that you have here. One is actually attaching an ACE and keeping those observations in the beginning that were not used in your model. The other is take your data, throw out the first two observations, and then add the fit to it. So this is how data 3 is looking now. This is how the other one looks. So basically, in one case, I attach an ANA in the beginning. On the other case, I throw out all of this before attaching my prediction without the ANAs in the beginning. Everyone understands?
Yes, but if you throw it out, doesn't it change the values? Because the first, at least in price, you have two numbers that you're getting rid of.
I mean, it doesn't change the values. It's just that you're just throwing away those two values. So depending on what you want to do, maybe you do not want to do that because maybe you still want to run other things with your data. And I don't know, maybe you want to also run a model between return and C price. And if you throw that out, now you actually have one last observation of that.
Okay.
Or between price and return. So it depends. If you're done, if the only thing you're going to do with that data, if you only had return and return, so if you only really wanted to look into return and return -1 and run that model at the end, it would be absolutely fine to throw out the first one for whatever you're going to do. Any questions? What about function syntax? Any questions on that?
Maybe if you could explain again why do you use the return at the end?
So the return at the end of any function tells you, and I mean, there's no return within the function, no function to return from. So return is basically something that you add to the end of any function that tells of all of the objects that were created within the function and that exist within the function. What is it that I want to be the output of this function? So in this case, the output of the function lag predict is a data set called result. So let me show you an example here. So let's say I do here, return 2, okay? Same function. Now if I do that, my data 2 looks 2. So basically this function now does exactly the same things. In the inside, it's calculating all these things. And then at the end, it just returns 2. Which is basically useless because when I run the function, all I get is 2.
Oh, okay. So to me, it seems a little bit redundant. So what is the purpose of having that return thing in the function?
Because if I do not have the return thing, this function calculates things, but doesn't really, well, in this case, it gives me something, you see? So if I don't add the return there, now it's giving me the predict.
Oh, I see.
It doesn't really know what is it that is the output. The return tells you on this function, what is the output of it? Of all of the things that were done in this function, what is it that I want to be the output? And it could be multiple things. I could be doing result and something else. It would probably give me a list in this case or not work. Let's see. Yeah, multi-arguments returns are not permitted, so that doesn't work. So I don't know, let me function example. So if I want to do a function of x and y, and I do x plus y, and I'm gonna call this z, and then I do return z. So now my function example 1, 2, this is gonna return the sum of 1 and 2. If I went on here and I said return x, now what I'm gonna get is the value of x. But still, when I run this line of the code, it is adding 1 to 2. It's just not returning the result of 1 to 2.
Oh, I see. I get it.
So this just tells you what is the output of your function. Think of this as the inputs, the arguments of your function, and that's the output. Other questions on function?
So every time we want to simplify a bunch of lines, we can just do a function.
If you're doing the same thing over and over and over, if you're gonna do the same type of calculation over and over and over, yeah, you can create a function for that. So let's say that you wanna, I don't know, let's say that you're gonna do lagged predictions of many different datas. You want to compare many of those. Instead of copying and pasting this part here over and over and over, and just changing what is it that you are shifting, what is it that you are predicting against, what is the data you're doing that, you can just have a function and then you have as arguments the things that are changing. So basically, so for example, with the Tom exercise that some of you did, I don't know if everyone here today is also at Tom's class, maybe not. But you were calculating the Gini for many other things. And you remember that when you copy and paste it and you were changing things, there were specific arguments there that you were changing. Everything else was the same. So basically you were kind of looking for certain terms in your code and substituting that for the next whatever argument that you needed. So instead of copying and pasting that and substituting whatever you were substituting, you just create a function with that. And those things that you would be substituting, you make those the arguments of your function. So Tom Strand, not Tom Masterson, sent me his code this last Friday, I think, or something like that, or Thursday, last week.
Yeah, sorry, I forgot to send that to you after we.
It's totally fine, but I mean, one thing we can do is exactly that, is show how we would transform that into function. But basically it would be that. It would just be understanding what are the things that I need to input here that I'm changing every time, and what are the things that are fixed. Those things that are changing, those becomes arguments. The things that are fixed, they are part of the function. I don't know if I have any. Yeah, I don't think any of the examples I would have on my codes would be helpful right now. Yeah. Okay. Any more questions? I can send you, where is it? Class line. I need to close some stuff here, right? I can send you this. At least send you the function.
Sorry, I need to run. I have another call here at noon. So see you later.
Okay. You will have this on YouTube, right?
Yes, it is on YouTube. Please ignore the part where I spent some time trying to figure out the shifting of the prediction, but I'm also gonna send this to you all. Yeah, I'll do that, and then you can look into what happens between data and data 2 here, and you have the code for the like prediction, and it's doing this because of the attach. There is another solution for this problem without having the attach. It's just that the code would be a bit longer, and I didn't want to make it more complex than it needed to be. Okay, so I'm gonna stop the YouTube part.
Thank you.